Today we're going to be going over 3D modeling, which is a part of a step in creating a robot called CAD. CAD stands for Computer Aided Design, and it's a key step in building a robot because it allows you to visualize a part without actually making it, which means you won't have to waste valuable resources. When you open up this program, which is called Autodesk Inventor, you'll be greeted with this screen. Here you have your recent documents, your projects, and the tab we're concerned with, the New tab. Under the New tab, click the Part button. Once everything loads, you'll be greeted with this screen. Here you have all of the options for whatever you want to do. Here you have the subsystems for your part, and here you have the part itself, where it will be displayed. At the moment we don't have a part, so it's blank. To create a 3D part, you have to start with a 2D sketch. That way you can get a profile for the part you want to extrude. So to start a 2D sketch, there's a button in the top left called Start 2D Sketch. Once you click that, it'll give you an option to choose one of three planes. We're going to choose the XZ plane, but in the future it doesn't really matter what plane you choose. First we're going to go over the line feature. This is pretty self-explanatory. You create a starting point and an ending point, and it'll create a straight line in between them. For our starting point, we're going to choose 0, 0 because it's obviously a very simple point to choose. Then here we're going to specify a direction in which our line is going to go. In this case, we're just going to go at 0 degrees. It automatically locks to 0 degrees because it's one of the 4 quadrantal angles, which means 0 degrees, 90 degrees, 180 degrees, 270, and 360/0 again. So at 0 degrees, we're going to just let it go up. And if you look at the highlighted box, you can see that that's basically the length of our line here. You can either drag it out and get it to as close as you want, or a more accurate way of doing it is you can actually type it in. See how it's highlighted? That means it's editable. So in your number line at the top of the keyboard or in your number pad, type 1. And that'll allow you to set the dimension for the line. As you can see, 1 inch is a little bit out of our scope. So this is a good time to go over basic Inventor controls. If you scroll up, that basically allows you to zoom out. If you scroll down, it zooms in, and if you hold the middle mouse, which is the scroll wheel, it allows you to pan around or move around. So get to a view that's perfect for you, and then we're going to continue. As with any part, you can't just have 2 lines and expect them to become 3D. You need to have a 3D figure itself. So we're going to assign a thickness to this. I'm just going to create a basic profile and come back. Okay, one thing to go over, if you're in the middle of making something and you want to stop it, press the escape key. That'll stop whatever function you're doing. Here's a cool part about Inventor. Let's say you have to do some calculations. Like here, you want to have a straight line that goes from here, but doesn't go until here. You want it to stop at this dotted line, as if to create a junction in between these. Well, you know that this is a 1 inch of length, and this is 0.125. So you know that to stop here, you'd have to do 1 minus this 0.125 here. So it's pretty simple, 0.875. But let's say it's something more complicated. You can actually have the computer do it for you. You'll type 1, and the minus symbol is a dash symbol, dash 0.125, and that'll just subtract 0.125 from 1. And see, automatically creates the line. And to check, when you connect to this, it should create a 90-degree angle, and it should be 0.875 as well, because these 2 lines are the same length. So when you connect them, bam, there's the part. So one thing here, we're going to go over another tool called Fillet. Fillet basically allows you to take 2 edges and create a curve. So in this case, you have the dimension here, which is 0.125. We're not going to change it, but you can change the rate. This is basically the radius of the fillet. So you can change it to 0.25, 1, whatever suits the need. So we're going to be creating it between these 2 and these 2. So the use of a fillet is basically to distribute a force over a larger area. That way, no one point is taking too much force, and that causes less stress in the area, which means it's less likely to break. So now that we have this part that's been filleted properly, we can press this button in the top right called Finish Sketch. So here's the 2D profile we're talking about. From here, we want to make it into 3D, which we're going to use a tool called Extrude for. Extrude basically recognizes or takes your 2D profile and takes it upward into 3D. In this case, because we only have one profile on the screen, it automatically extrudes it into 3D. So we're going to set the dimension as 3 inches here, so that we have space to work with later on. Once you do that, bam, you have your first 3D part. So now let's say you had to edit the part. It would be very similar to creating a new part where you would press Start 2D Sketch, but instead of choosing a random plane, you would choose a plane on the object you made. In this case, we're going to choose this inner plane. What we're doing here is we're going to create holes to be able to mount this bracket onto something else. Make sure you know the X and Y dimensions of your holes before you actually plot them. Because what you can do is you can plot X this way, Y this way. So it'll be easy to plot the holes. For example, we're going to have the two holes be 0.75 and 2.25 respectively, and both of them are going to be 0.5 inwards from here. Note that our reference point is this edge rather than 0, 0, so make sure that when you're creating your actual part that you take into your reference point. So now that we have the locations of both of our holes, we can use the circle feature to create a basic shape of our hole. So we're going to click on this endpoint because that's the point at which our hole is going to be. We click on that, and now it's going to ask us to input the diameter. As you can see, the blue box is highlighted is the diameter of our hole, and in this case, we're going to be making that 0.25. It's always better to type in the diameter rather than just estimating because it's more accurate. We're going to do that here again, 0.25. And there are two holes. Once you're done with this, you can press Finish Sketch. And then you can press the Extrude button, because once again, we have our profile here for the extrusion we want to make. So you press Extrude, and you click on these two holes. And that's a problem, because we want to make holes. We don't want to make them. We don't want to add more to this part. So there's actually an option under the Extrude panel called Cut. Cut basically, instead of adding to the part, it cuts in the opposite direction through the part. So if we press Cut, you can see that it reverses direction and it actually goes through the part, leaving this hole here, which is what we want. So choose the Cut option, and in this case, it's 0.125 thick. Since we're just cutting, it doesn't matter if we go more, but it's better to choose it the exact distance you want to cut it for more precision. So we choose 0.125 and we press Enter, and those are our first two holes. After finishing the holes on one side of the part, you can repeat the process for the second side of the part to get the same result. Now, we're going to create the two parts for which we're going to use this to attach. To create a new part, there's a New button in the top left corner. If we click the arrow next to that, it will bring a drop-down menu in which you have 4 options. Press the Part button to open a new part. Here, we're going to press the Start 2D Sketch because once again we need a 2D profile to create a 3D extrusion from. Press the 2D sketch and then choose a plane. So now we're going to use the rectangle tool. This tool is used if you know both the length and the width. That way you can knock everything out in one go. So in this case, we're going to be creating something called a 2x1, which means it's 1 inch wide by 2 inches tall. So we're going to input 1 up here, and to change to this other dimension, we can press Tab. That allows us to change to the other dimension. As you can see now, it's highlighted. This will be 2, it's 2 inches tall. When you press Enter, you have your 2x1, 2 inches tall by 1 inch wide. But of course, a 2x1 has to have a thickness to the metal. Otherwise, this is literally just a 2D sketch. So we can add a thickness by having the same figure but offset a little bit inwards. So if you go to this Modify tab, there's an Offset button. This Offset button basically takes whatever figure you want and offsets it inwards. So if we click on this figure here, it'll give us an option to offset it by a certain distance. In this case, it's going to be a 2x1 by 1/8. The last number defines the thickness of the metal, which is 1/8 inch. We can either do 1/8 by doing a 1/8, which will do the math for us, or we can type 0.125. Once again, this is always useful to do the math for you. Just do 1/8. 1/8 will do the division for you. 0.125 right there. So this is the profile of our 2x1. After you're done, you can press Finish Sketch, and you should have this. When you press Extrude to create the extrusion, you're going to have to extrude this outer bit. There's two different bits here, the inner bit and the outer bit. But the outer bit is actually the stock metal, so that's what we have to extrude here. Of course, you can't really have a 1-inch piece, so we're going to have it extruded to about 5 inches just for convenience. Once you choose the length, press OK, and there you have your part. The final part of 3D modeling is creating an assembly. An assembly is used to put all the parts together to create the final product. For example, once you create all the parts of a robot, you can put that together to make the full robot. To create an assembly, you have to go to a new tab in the top left corner again. When you click on the down arrow, the first option to drop down is the assembly option. Click that. After a little bit, the assembly will load. Here, you'll be greeted with the blank screen much of the part, but you'll notice that none of the options are the same as creating a part. Instead, you have the place option. The place option is to place components for your assembly. So you can go through and look for your parts. Otherwise, if you have the parts already open, you can copy and paste the parts into your assembly. If you click on the part name in the top left corner, where you see my mouse, you can press Ctrl+C to copy it, and go to your assembly, and press Ctrl+V to paste it. I'm going to be pasting 2 of these parts, because we need 2 of them to be connected by that one bracket. Now I can go to part 1, which is our bracket, click on the part, and Ctrl+C it. When I go back to the assembly, I'll paste it using Ctrl+V, and there we have all the parts for this assembly. To create the relationship between the parts, we have to use something called constraints. Constraints basically relate the 2 parts in one way or another, whether it be by the edge or by the faces. So you can press Constrain, and it'll bring up this option. It's automatically in mate mode, which means that it's going to connect the 2 parts directly. So the first thing to do with a constraint is always to do a face-to-face constraint. That'll give you a reference point so that the 2 objects you want connected are on top of each other. After you do that, you can press Apply. If you look here, this doesn't look right. You have the part on the other part, but you can see that this is going off the edge, which makes it look a little awkward. So the best way to deal with this is to flip this 90 degrees so that this is flush with this. Which brings us to the next type of constraint, a flush constraint, which basically makes sure that the 2 objects you select are flush. This requires you to select 2 faces because you can't really flush an edge. An edge can be flush into another face in many different ways. So we'll choose this face and this face to be flush with each other. And as you can see, they're now on the same plane and they're parallel to each other. You can press Apply. The final thing we want to do is make sure that this part is on the edge here. To do that, we have 2 options. We can either flush these 2 parts, or we can go back to the mate mode and we can actually mate the edges. By mating the edges, we're going to make sure that the edges overlap on each other and they're connected. This produces the same result as a flush in this case. You'll see that a lot of times, there's 2 different ways to mate something to get the same result. Once you get your relationship, you can press Apply. We're going to repeat the same thing with this part. Here we run into a slight problem. Normally we flush this bottom plane, which is beneath this, with this, but the bottom plane is hidden. So this is another example where we'd have to use the edge constraint. Using the mate tool here, you can use this edge and this edge to mate it to each other. And finally, we're going to end with them flush. You can flush these 2, and they're flush with each other. And that's how you make 2 objects. There are a few more types of constraints that are very common. Of the most common are the circular constraints. Circular constraints use circular references as a reference point to constrain one object to another. For example, if you had a bolt in a hole, you would constrain the bolt through the hole using circular references. There are 2 types of circular references. First, you have the pathway, which basically takes the circular path all the way through, and it constrains it with the circular path of another object. This allows you to basically constrain two objects on a certain path. As you can see here, these are both constrained on the center point of on the path of the center point of both objects, and you can move it along. The other type of constraint basically takes the center point of a certain circular face and makes it another one. For example, if we were to make this circular face with this circular face center point, it had made it at the center point. As you can see, now that they made it at that certain center point, you can't move them anymore because they have a certain point at which they made it. It's like mating two different lines. Now they're attached to that line, so you can't move it anymore. The last type of constraint we'll be going over is a motion constraint. A motion constraint basically creates a motion relationship with two different parts to make sure that when one moves, the other will move. For example, when you spin this gear, this other gear moves, and then this gear moves because of this gear. That's because there's a relationship between the gears that not only causes one to move, but also move according to the specific gearing. So to do that, you have to make sure that all the parts are already in place. As you can see here, these parts are already in place in the gearbox, so we can do the motion constraint. So when you go to constraint, there's this tab here called motion. When you do that, the first type is already rotation. Now we have to choose the reverse, because when this spins in one direction, this will spin in the other direction. So we'll give this one spin, and we'll give this the other spin. Now the ratio between the two gears is 14 tooth to 52 tooth. So you should do 14 divided by 52. This basically tells the computer how fast this has to spin and how fast this will spin in relation. We need this because otherwise this could be spinning at like 100 RPM, and this would be spinning barely fast enough, which doesn't make sense because this is a smaller gear, which means that it should be spinning faster than this. Once you put your ratio, you can press apply, and as you can see, when you spin this, these are all spinning in time with this gear. Thank you for watching this tutorial on 3D modeling. I hope that I was able to teach you some Autodesk Inventor and that you have a better understanding of CAD. CAD is an amazing concept that has many different applications and has many different opportunities available. So thank you, and I hope that you can keep on learning and keep on CADing.